Hello and welcome back to lesson number 2. And what's the topic today? We're looking at factorial notation and permutations. So today's goal, I want you to be able to explain what factorial notation is, and then I want you to be able to apply factorials to simple problems and to applications like permutations. Okay, so we'll talk about what each of those means as we go through. So the first thing is a couple definitions with the counting principles. So to start with, we're looking at rule of sum and rule of product. So the first thing I want to look at is rule of sum. The definition for rule of sum. So the rule of sum, it is simply this. How many ways one or another event can occur? And here's the key thing. Data management comes down to semantics. And semantics is simply the words or and a lot of times. So how many ways can one thing or another occur? So the word or appears in the question. So here's an example. Okay, how many ways can you draw a 4 or a queen from the deck of cards? So if you're doing a tree diagram here, you can't just stem off from a 4. You'll have two choices here. You have to add the totals together. And in this case, how many ways can you draw a 4 or a queen? Well, there's 4 4s. There's 4 queens. So 4 plus 4 is where we get the 8. So if you see the word or, you know you're using your rule of sum. For rule of product is how many ways can 2 or more things occur one after another. And usually the word associated with this is and. How many ways can you draw a 4 and a queen, for example? Okay, so there's the rest of the definition. So usually the word and appears in the question. So you are looking for these two words. So please make sure, kind of highlight this for yourself. Or and change the question significantly for us. So, example. How many ways can you draw a 4 and then a queen from the deck of cards? So very similar to the question above, except we have and instead of an or. Okay. So there are two rules. So rule of sum is when you're doing an or. Rule of product is when you're doing an and. So sum can't happen at the same time. I can't draw a 4 or a queen at the same time, so I'll have to add those cases together. I can draw a 4 and a queen, so therefore we'll have multiplication. All right, moving along then. What is factorial notation? So that's where we'll start today. So factorial notation is simply, so factorial notation allows us to write consecutive, make sure I get this right, consecutive integer multiplication efficiently. Okay, so what does that mean? It means if I have 5 times 4 times 3 times 2 times 1, or I have 7 times 6 times 5 times 4 times 3 times 2 times 1, instead of having to write that again, we can simply write it as the following notation. You take the largest number being multiplied, and you use an exclamation. So factorial is really excited. So 5 times 4 times 3 times 2 times 1 is really 5. I'm just making that up. You don't actually have to say it that way. Or not, if you don't realize that I use sarcasm. Okay, so the exclamation point represents what we call factorials. Okay, so why are factorials important? Well, it's for that exact reason above. So if I use a simple example here, i.e., how many ways can you pick 20 names from a hat? Can you pick 20 names from a hat? So setting up how we talked about with the fundamental counting principle, the first person, second, third, fourth, so on. So the first person out of the hat, you have 20 options. The next one person's gone, so now you have 19 options. Next one's gone, you have 18, 17. So do you really want to continue to write this out, or can you simply see the pattern and say, hey, 20 factorial is my answer? So it is a more efficient way, okay? It's more efficient. More efficient. And secondly, we need the notation. So if this is number 1, this is number 2, we need the notation for, and I'm going to introduce 2 new words to you, permutations and combinations. And we're going to talk about each in their own time. So don't worry about yet whether you know what that means. Okay. A couple of interesting things down here. Some more examples and important notes about factorials. Just a couple of things that I want you to be aware of. We're not going to do a ton of algebra or anything with that, like that, with this, but I just want to talk about some of the things that that arise that you need to know. So for example, if I had, first thing I want to talk about is what happens if I had a factorial? What happens if I have a variable factorial? What does that look like if you expand it? Okay, well, it's the largest term multiplied by 1 less, so it would look like this, a minus 1. Take 1 away from it, multiplied by a minus 2, multiplied by a minus 3, so on and so forth. Okay, until you reach 1. All right, so that's one thing I want you to be able to do. I want you to be able to understand how to use variables when they come up with the factorial notation. Second one, what happens if we get 0 factorial? Someone's going to ask that. Factorials only exist for our counting our whole numbers. So maybe I'll just go back up here for a second and put it right under here. Only exists for whole numbers. And your whole numbers start at 0 and go up, and they're positive integers, remembering from grade 9. So what happens if you do get 0 factorial? 0 factorial, by definition, is 1. Okay? So I'm going to go by definition. All right. When you multiply factorials, so for example, 2 factorial times 3 factorial, it's not equal to 6 factorial. All right, so those rules don't exist. There's no shortcuts with it. Okay, so please don't do that. On your calculator, if you have the right calculator for this course, factorial button always looks like this, and end with the factorial notation. So that's our calculator button. All right, the last thing I want to look at is division with factorial notation. So what happens if I have 7 factorial over 3 factorial? You can obviously use the calculator to calculate this out, but I just want you to see something that comes from this. On top, the 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 3 factorial, 3 times 2 times 1. Whatever you do at the top, or sorry, if it's on the top and you do the same thing on the bottom, they cancel each other out. So this just simplifies to 7 times 6 times 5 times 4. All right, so that when you do that division, that whatever you're dividing by cuts off the tail end of it. So just one more example with that. If I go, let's go 9 factorial divided by 6 factorial. I don't want to go through and write it all out like I did in the first one. I don't want to go 9 down to 1, 6 down to 1. I know that that 6 factorial will cancel out the 6 factorial on top. So one way to think of it is like this. 9 factorial is 9 times 8 times 7 times 6 factorial. So instead of going 6 times 5 times 4 times 3, I'm going to shorten this up, divided by 6 factorial. Now the factorial notation will cancel out. So this is just equal to 9 times 8 times 7. Okay? So you do need to be able to do that. That's the extent of the manipulation or the algebra, okay, when we're dealing with the factorial notation. So permutation. Excuse me, what is a permutation? All right, permutations are as follows. Permutation, oops, permutation is a calculation to determine how many ways and we'll go with n distinct objects. So n is just a variable. Distinct objects means that they're unique. There's no clones. Okay? So how many ways n distinct objects can be arranged? All right. So, for example, what's the notation? I guess I'll do that first. So, what's the notation? So, capital P, and it'll be N and R. Or, and you can use whichever notation you feel comfortable with. This will be the notation that's on your calculator, and you can also write it this way. I'm not a big fan of this because I hate subscript. It all starts looking the same. Try and do this one neat. Okay, NPR. Those are your two notations where and here's your legend. N is the number of objects. And R, and I'll do some examples, number to be chosen. Okay. And the question then, what is the formula? So the formula, I'll put that in here. Formula is as follows. The permutation of n choose R is n factorial over n minus R factorial. Okay, so there's your formula, and that's why we had to talk about the factorial notation. Okay, now the neat thing with that, and I'll just finish up, and this is the point where I'll finish. Oops. So here's the formula, stick it under there. And I'm just going to do a quick example. So let's talk about this. What happens if you have the permutation of, and I'm going to keep the numbers small, 5, 3. Permutation of 5, choose 3. So that would mean you'd have 5 factorial on top. I'm just looking at the formula. And then on the bottom would be 5 minus 3 factorial. If I simplify it, you'd have 5 factorial over 5 take away 3 is just 2 factorial. The 2 factorial would cancel the 2 factorial on the top, so the answer is just going to be 5 times 4 times 3. Okay, so that's how the formula works, and that's why I had you, or why I showed you this previous slide, and more specifically the bottom on the fractions. All right, now, are you going to calculate out in longhand? Absolutely not. There'll be a couple questions that'll say, go ahead and do this, please, using the long form of the formula. But for the most part, I want you to use the button. So it's very important to find the button on your calculator. And like I said, this right here is the notation that you do see on the calculator button. So make sure you can find that button. It'll likely be located near the factorial button, the n factorial. If you don't have a calculator with those buttons, I would highly recommend finding one that does. I'll finish this note up in the next video, and then you can go ahead and try some homework.